right, these are the notes for 3.6. It's quadratic inequalities. So this time, instead of having the equal symbol, we're going to have this greater than, less than, greater than or equal to, or less than or equal to symbol instead. Okay? And it's always y on one side and your quadratic on the other. Okay? Now, this says to use a test point to determine whether the point is a solution. Okay? Because when you have an inequality, if you can see what's shaded here, like this is shaded, that means a point in here, if I were to take this point and plug it into an equation, it would make that equation true. If I plug in a point that's not here, then it would make that equation false, or that inequality false. And so that's how you determine where to shade when you're doing it, if I plug in a test point. So, so I have y is less than x squared plus 2x minus 8. I have it as greater than, I have less than or equal to, and I have greater than or equal to. And we're trying to match these up. Well, I know that these ones with equal to are going to have a solid graph. Okay, you need to know, is it dashed like these, or is it solid? Well, these do not equal the actual equation itself. It's just greater than or just less than. So that automatically tells me these two have, because they don't equal, have to be these dashed ones. That's what the dash means. It's like going up to it but not including it. And you can also tell because these are negatives, so their graph's going to go down. And these were positive, and these graphs are going up. But what you need to first look for is it going to be dashed, or is it going to be solid? So I can tell these are dashed. I'm going to write that down. And I can tell that these are solid. Okay. Then I want to determine, without even having to plug in a point, is it graphed below or above? If y is less than, y gets smaller as it goes down. So I know this has to be shaded below. Where this one says y is bigger than this and get bigger going up, so it's shaded above. This one will be shaded below because it's less than or equal to, so less than is as it's going down, and then this one will be shaded above because it's greater than. Okay, so I want to find the one that's dashed and shaded below. But below what? Okay, so I know it's one of these, and I determine what? I like to think of its vertex. It is shaded below its vertex. If I go right below it, it's shaded, and then you have to shade everything outside. So I know that this is A. A matches with number 1. And I know this one's also dashed and is shaded above. So if I go to its vertex and it's shaded directly above it, whoops, that's not B, that's C. I had the wrong letter there. Okay? Then if I look at B, I know it's solid and shaded below. Well, this one at its vertex is not shaded directly below it, but this one is. So I know this is B. This one is solid and shaded above, which is that one, and so that is D. Okay? So when you're actually graphing these inequalities, first off, you need to remember how to graph your quadratics. And we need to figure out, is it dashed or solid, shaded above or shaded below. So I always like to make that note first. I can tell it's not equal to, so I know this is going to be dashed. And it says y is less than. So I know it's going to be below. Okay? And then I'm going to graph it. Don't forget those points to memorize. But I know there's no movement left or right, so I'm just going to go up to, and I put my point. And the points to memorize were 1, 1. There's no multiplier in this one. 2, 4. And 3, 9. Well, 3, 9 doesn't fit. So now I don't want to just go ahead and plot my curve because I need to make sure I dash it. That's why you need to make that note beforehand. So after you, or when you're ready to draw the actual U part of your curve, of your parabola, you get it right. And then I shade below. Well, if I go, here's my vertex, below it is here, so I know this all has to be shaded, but you have to shade everything under your parabola. So this is actually considered the outside of the parabola, and this is the inside. Now, to double check, let's give it a test point. Something that I can very clearly see should be in my solution, it would be 0, 0. So if I plug 0, 0 in, so I'm just going to do a little test here. Sorry about that bell. I'm going to do a test point, and I'm going to plug in 0, 0. So I have 0 for y less than 0 squared plus 2. So 0 needs to be less than 2. And it is. So this is true. So it worked out. Okay? Now I go on to this next one. I know that it's going to be solid because it has the equal to part, so it's going to be solid. And again, it's shaded below. Now, this time I have a multiplier. So if you need to, when you have multipliers, go ahead and write down your points. 1, 1, 2, 4, 3, 9. Multiply the y's. Obviously, these two won't fit on a graph this small. So I plot my start point, my vertex. There's no movement left and right. There's no movement up or down. I'm at 0, 0. And I'm going to write 1 down 5. So that actually takes me right to the edge of my graph. This is solid. So no dashes. And I shade below. So if I go to my vertex here, here's my vertex. I'm going to go directly below it, and that's what's shaded. So I'm shading inside the parabola because it's on the inside of my curve. Okay, and let's do a test point. So in this case, you can plug in anything, but I can tell -1, 0, or 0, -1, sorry, is inside where I shaded. So I'm going to try that. I'm going to try 0, -1. So I plug in. I have 0 less than or equal to -5 times negative. I just plugged them into the wrong spot. I'm sorry. This is -1. This is 0. I promise I will be a little more careful. Okay. And so I have 0 squared is 0. -5 times 0 is 0. Is that greater than -1? Yes, it is. It all checked out. Okay. All right, now this one is going to be solid, and it's going to be shaded above because y is greater than. Now I have movement left and right, so instead of going +4, we do the opposite. We go -4, and that tells me I go down 1. So there's my vertex. My multiplier is -1. So all my y values would have, instead of 1, 1, 2, 4, 3, 9, are going to become negative. From this vertex, I'm going to go right 1, down 1, and mirror it. I'm going to go right 2 and down 4. It is solid. And I shade above. Well, go to vertex. Above is up here, so the outside is what is shaded. And again, pick a point to test. I'm going to pick 0. 0, 0 is the easiest to pick. I just didn't pick it on this one because it would have been exactly on my graph, and I'm trying to make sure my shading was correct. So I needed to find something within my shading. So I'm going to plug in 0, 0, see if it worked. I have 0 greater than or equal to a negative 0 plus 4 squared minus 1. So I have 0 greater than -16 minus 1, oh, greater than or equal to, sorry. And yes, 0 is greater than or equal to -17. Okay, graph this last one. Now, this is not in graphing form. So, these ones were in my graphing form, my vertex form. This is not. This is standard form. So what standard form tells you, well, if x is 0, I know y is 1. So that tells you your y-intercept. I can plot that easy enough, but I'm going to need to use stuff from the previous chapter to be able to plot this. But let's first, it is going to be dashed, shaded below, okay? Because it's not less than or equal to, it is just less than. All right. Now, standard equation, if we wanted to find our vertex, which is x comma y, remember the x was -b over 2a. And then we plug that into the equation and we find the y. Okay? So we're going to get a negative half, 0. So I have a vertex, and when you mirror things, it looks like that. This is the graph. Okay, and this is dashed, so I cannot make it solid. And then it says shade below, so I go to my vertex, go down. This is below. Now this time 0, 0 is in my shaded area. So let's plug in 0, 0 and see if it's true. 0 less than 4 times 0 squared plus 4 times 0 plus 1. 0 less than 1. That is true.